Suppose the owner of your favorite coffee shop asks for your help in trying to understand the customer experience in the coffee shop. They want to know how long it takes a person to get serviced in the morning. You tell your friend, there is a single server in your coffee shop, and I know how to analyze a queue with a single server. So you visit the coffee shop and you see that the inter-arrival times are uniformly distributed between 0 and 2 minutes. You also measure the service times and you also find that they're uniformly distributed, but between 20 and 80 seconds. But then you realize something. The MM1 formula has two important assumptions in there. The first one is that the inter-arrival times are exponentially distributed, not uniformly distributed. And the second one is that the service times are exponentially distributed, not uniformly distributed. So neither of these distributions satisfy the assumption of the MM1 formula. So you can't quite use the MM1 formula. You're going to get a wrong answer if you do that. So how do you analyze a queuing system when you don't have the formula to analyze it? Instead of using a formula, we're going to build a simulation. And we're going to build a simulation in Excel. And here's how this is going to work. We're going to have lots and lots and lots of rows in our spreadsheet, and each row is going to represent a new customer. And we're going to have 5 columns in our spreadsheet capturing the information that we need to know about each customer. The first column is going to have the inter-arrival times. That is the time between 2 customers arriving in the coffee shop. The second column is going to have the actual arrival time. That is, what is the time that this customer arrived in the coffee shop. The third one is going to have the wait time. That is, how long did that customer wait in line, which at the end of the day is what you want to know. The fourth column is going to have the service time, which is how long it takes to service a customer, how long it takes to get that customer his cup of coffee. And the last column is going to have the completion time, which is at what time did the customer get the coffee and leave the system. So let's start filling out the spreadsheet. In position A2 in the spreadsheet, we're going to put the first customer's inter-arrival time. This is the first customer, so the inter-arrival time is actually the same thing as the arrival time, and we know it's uniformly distributed between 0 and 2 minutes. So we're going to use everything in seconds here to make sure that everything is in the same unit. So the inter-arrival time of the first customer is going to be random between 0 and 120 seconds. The function that we can use to generate a uniformly distributed random variable in Excel is rand. Rand is going to give you a random number between 0 and 1. So to generate a random number between 0 and 120 seconds, we're going to put in the formula here in A2, rand times 120. In cell B2, we're going to put the actual arrival time of this customer. And again, this customer is the first one to arrive. So we're just going to put in cell B2 equals A2 because the arrival time of the first customer is equal to his inter-arrival time. This is the first customer coming in the store in the morning. That means he doesn't face any queue. That means he doesn't wait at all. So in the third cell, at cell C2, we're going to put 0 seconds. 0 is the number we put there. In the fourth cell, we're going to put the service time of the customer. The service time is again random and uniformly distributed between 20 and 80 seconds. To create a variable that's uniformly distributed between 20 and 80 seconds, we can use the formula 20 plus 60 times rand. And that's the formula we're going to put in cell D2. And now we're going to complete the first row, that is, complete the row for the first customer, by putting in the completion time of the first customer. So when does the first customer leave the store? It's going to be the sum of his arrival time plus his wait time plus his service time. And that's B2 plus C2 plus D2. Let's walk through an example to make sure we're all on the same page here. Suppose the first customer arrived 60 seconds after you opened the store. Therefore, the random number that's going to show up in cell A2 is 60 seconds. In cell B2, we're also going to see 60 seconds. That's also the arrival time of the customer, not just the inter-arrival time. In cell C2, we're going to see 0 because this customer didn't wait in line. And let's say the service time for the first customer is 40 seconds. Then what is the completion time for the first customer. The completion time is going to be the sum of the second, third, and fourth columns, right? The arrival time plus the time it took the customer in waiting plus the time it took to get the customer serviced. So it's 100 seconds in this example. All right, now we need to calculate the wait time of customer 2. This is where things get interesting. Because for the first customer, the wait time was really easy. It was 0. The first customer never faced the line. But the second customer might. So let's go back to our example. In our example, the first customer arrived after 60 seconds, and he got his coffee after 100 seconds. Now let's assume that the second customer's interarrival time is 20 seconds. If the second customer's interarrival time is 20 seconds, that means his actual arrival time is the sum of B2 plus A3, so it's 80 seconds. That means second customer is arriving 80 seconds after we open the coffee shop, but the first customer's service is not completed yet because the first customer only gets his coffee at time 100 seconds. So how long does customer 2 have to wait? Customer 2 is going to have to wait 20 seconds until customer 1 is done. So what is the formula here that we need to use? The formula here is E2 minus B3, the 100 seconds minus 80 seconds. And why is that the case? Because that's the difference between the time it takes to service the first customer minus the arrival time of the second customer. This formula is almost right, but not exactly right. Let's now consider a second example. Let's say the customer 2 didn't arrive 20 seconds after customer 1, but 60 seconds after customer 1. If customer 2 arrived 60 seconds after customer 1, customer 2 arrived in the store 120 seconds after the store opened. If customer 2 arrived 120 seconds after the store opened, customer 2 arrived after the first customer was gone, because the first customer was serviced in 100 seconds. So what is the wait time? If we use the formula we had before, E2 minus B3, we'd get a negative wait time. We'd get the customer 2 would wait minus 20 seconds. That's not quite right? Nobody can wait a negative time. So the right answer here is customer 2 is also facing an open queue with nobody there. So customer 2 gets serviced immediately, and he has no wait time. So the wait time here would be 0. So how do we square these two formulas? The way to do this is to put a max between E2 minus B3 and 0. And that's just going to ensure that if we were going to have a negative wait time according to our wait formula, we move this to 0 because nobody can wait a negative time. The next step is to calculate the service time of customer 2. So the service time of customer 2, just like customer 1, is uniform between 20 and 80 seconds. So we're going to use the same formula we used for customer 1, which is 20 plus 60 times rand is the random service time of customer 2. And what is the completion time of customer 2? Again, it's the same formula that we use for customer 1, which is the sum of customer 2's arrival time plus customers 2 wait plus customers 2 service time. So the formula is B3 plus C3 plus D3. And with that, we're done with customer number 2. For customer number 3, we can use the same formulas that we used for customer number 2. And actually, we can do the same formulas again for customer number 4. So all we need to do is copy the row for the second customer many times. So let's say we copy this 999 times, so we end up with a simulation of 1,000 customers. After we copy this, we have a giant spreadsheet that's going to simulate how do the first 1,000 customers get serviced in our coffee shop. And now we can estimate the average wait time of a customer in this coffee shop. We just need to take an average of column C. So you put in the formula average from C2 to C1001. That is an average of the first 1,000 guys. And that's going to give you an estimate of how long a customer waits in the store. At this point, I recommend that you go check out the simulation spreadsheet that was provided to you. It looks exactly like the one we built here. In your simulation spreadsheet, what was the average time that it took a customer to get his cup of coffee?